So seams are such an important concept that I'm giving them a little section all to themselves. And basically, this is this definition, which is my favorite one, is from Michael Feathers, who wrote a book called Dealing Effectively with Legacy Code. And a lot of what we have in our book about legacy code is really inspired by his framing of the problem. So his definition of a seam is it's a place where you can change the behavior of your application without changing the source code. So it's useful for testing because one of the things we need to do in unit tests is isolate the behavior of the code that we're testing with these particular tests from the behavior of other things that it depends on. Right? So even in the example we just saw, suppose we actually had already coded our find and tmdb method in the movie model. One possible reaction would be, well, in that case, you no longer need to have a seam where you're essentially faking out the behavior of code that doesn't exist because, hey, the code exists now. But the real reason to use the seam is not just because the code doesn't exist immediately. It's because if the code existed but was broken, or if somebody else had made a change to the code that might have caused your test to fail, the idea is you can still test in isolation the other things that depend on that code. You can break that dependency by a tastefully inserted seam. So should receive is an example. It uses Ruby's open classes to create a seam for isolating method calls from each other. And happily, after every single test case, RSpec basically resets all of the seams. So if there's a seam that I'm temporarily creating, like I did in our example because I wanted to spy on a method that didn't even exist yet in the movie class, well, if that method had existed and I chose to spy on it, after my test case finishes running, for the very next test case, that stunt double or that spy is torn down. Now, that means that in every test that I want to spy on, I have to reestablish that condition, which is not a big deal. We'll see that there are ways to sort of do it for a group of tests at a time. But the important issue is I can keep tests very independent this way, right? For a very specific test, I can say, I need to stub out these places where the test depends on other things. And I need to have a controllable, canned behavior of the things that it depends on, because that makes my test execute predictably. That's what gives me independence and repeatability and the other things that are nice about tests. So we already know that we could write, we have a spec that's going to fail because we wrote the spec, but the controller method, we emptied the body out. There's nothing in there. So what's the minimum amount of code? Remember, the goal here is what's the least amount of code we can write that would make our failing test pass, that would make it go from red to green? Well, the expectation, the should receive, said we believe that the controller method should call movie find and tmdb. So a logical thing for us to do to pass the test would be, let's actually make that happen. And here it is. Here's my modified controller method. All I have done is add a line that does exactly what the test says. It calls find in tmdb. It passes params from the search terms. Now you could say, is there actually anything being tested here? Well, there kind of is, right? As a programmer, I just made the assumption that if I look at params search terms, that that's where the title of the movie would have come in from. And if my simulated post in my test case doesn't match that, or if I was wrong about the name of the form fields or anything like that, even this trivial test would help find sort of that level of stupid error. Now, it's still the case that we don't have the find in tmdb method in movie. We have yet to write it. But the important thing is we have actually verified something about what's going on here, right? We have, in fact, we've done a couple of things. We've done a couple of things. We know that the spec, we could say that it drove the creation of the code that goes into the controller action. It made us think about what the controller action has to do. It made us think about what external entities the controller has to depend on to do its work. In this case, it depends on a method in the model. And it made us realize that even if that method in the model happened to already exist, for the purposes of testing, there's an articulation point between the controller and the model. And that's a good place to put a seam so that we can keep separate the behavior of this test from the behavior of the things that code depends on. Now, one thing that we haven't really addressed is, all right, we haven't written find in tmdb, but shouldn't it return something? I mean, at this point, all we had done, all we've done is call it. We haven't actually said what it should return, right? We did the minimum necessary to make the spec pass, but it's not clear that this is going to lead us to the code we actually need. And we're going to return to this in just a moment. But in fact, I'm sort of making the example almost pedagogically a little bit oversimplified because I'm trying to drive home an important point, which is that one test maps to one behavior. The one behavior we should care about in this test is the controller action calls find in tmdb. Now the question, should find in tmdb actually return something? And if so, what happens to that data? We just haven't addressed that yet. It doesn't mean we don't care about it, but what find in tmdb should return, that's going to be something that's tested by the code that tests find in tmdb. What should happen with the stuff that it does return? Well, that's a question of what is going to happen when we try to generate the view, right? Because the whole point of calling the model is to get information for the view. So we're going to we'll answer those questions in just a moment, but let's take stock for a moment of where we are. We're going to start a list of things we know how to do in a test. We can set up this expectation that says certain objects should receive a certain method call, and we can optionally specify what argument is supposed to be passed to it. In this case, we cared, right? We cared because one of the things we were testing is the controller's got to get data from the user and make sure that the correct aspects of that data make it all the way into the model method. So in our case, we cared both about the fact that find in tmdb gets called and also about what argument is going to get passed to it. Both of those things are relevant to the behavior of it should call a model method that is going to actually query the database. But there are some cases where you care only about one or the other. For example, if I just care about whether a method is called and it takes no arguments, or for whatever reason this test case is only concerned about control flow and not about what data is getting passed, I can leave out the with. And that means that as long as the method is called at all, no matter what argument, the expectation will be correctly fulfilled. Okay, so this is one of a set of things that we're going to learn how to do that allow us to specify in a test what is the thing that should happen, and then how to go back and backfill the code to make that thing actually happen. So let's make sure we all agree about being on the same page about this. Eventually, we'll have to write a real find in tmdb method. So when that happens, what are we going to do? We can replace the call to should receive with a call to the real method. We can ensure the API to the real method that we wrote matches the API that we thought we wanted when we originally did the test with should receive. We should keep the seam exactly as it is, but we might have to change the way the seam looks because when we actually wrote the method, the API turned out to be different than the one that we had in our original test. Or we could just remove the entire test case that we wrote because now that find in tmdb exists, the test case isn't testing anything interesting anymore. So, thinking.